about graphing exponentials, right? Y equals a times b to the x power. Do you remember what we plugged in for that? What did our t-chart look like? You plug in for your x values, right? -2, -1, 0, 1, and 2. And then we got something that looked like this. We got our asymptote here. And then it was the graph was either on its way up or on its way down, but it would never hit that horizontal line, okay? Today, we're going to be graphing logs. And what did we say logs are compared to exponentials? They're inverses, the opposite, if you will. They are inverses, okay? So if we are doing inverses, we're going to reflect our original exponential graph over the line y equals x. And if we do that, right, if I were to take this and reflect it, now my asymptote is here, okay? So instead of the asymptote being the x-axis, now the asymptote is the y-axis, the line x equals 0, and my graph will be approaching the y-axis, but will never hit it, okay? So it's very similar, but you can easily make mistakes if you do it the same way as we did it before, because now, if you think about this, okay, if we're gonna graph a log, we've never graphed something like this before, right? And you can't graph something like this without your calculator unless you rearrange it. And I'm not going to let you use your calculator, so you're going to have to rearrange it, okay? Here's what we do. You know a different format for that. Can anyone tell me what it is? What to what power equals what? In this 3 to the y power is equal to x, okay? So that's your first step whenever you are graphing a log, is you're gonna turn it into exponential form, okay? So it's this to this power equals that, right? Now, we kind of had it written the other way. If it makes more sense to you to write log base 3 of x equals y and then set it up, 3 to the y power equals x, that's fine. It's the same thing, right? But you need to first rewrite. So that's our new equation, and that we know how to graph. But look at your setup here. If I plug in a -2 and a -1 and a 0 and a 1 and a 2 for x, is that easy to solve? No, right? You're asking yourself 3 to what power equals -2? Good luck to you. That's awful, okay? So instead, think of it, if we're doing inverses, we're swapping our x's and y's. So let's swap our x's and y's. We're going to plug all those numbers in for y instead now. Okay, so it really is very similar. But what? Yes, that's what I'm saying. So what we did before in 7-1, we did this, right? Now that we're doing the inverses, we're going to do this. That make sense? So we're going to plug them in for y because that one is easy to solve for. 3 to the -2nd power, 3 to the -1st power, 3 to the 0 power. Okay, so we're going to plug those numbers in. Let me get all this junk out of here. Okay, so 3 to the y power equals x is what we're plugging them in for. So this is going to be 3 to the -2nd power. What is 3 to the -2nd power? What? 1/9, yeah. So it's 1 over 3 to the 2nd, which is 1/9. Okay, so we plug it in for the -1. 3 to the -1st power is 1 over what? 3 to the 1st, which is 1/3. Do you see why we're plugging it in for y instead, right? 3 to the 1st is easier than 3 to the something equals 1. That one would be pretty simple. But for the most part, it's easier if you do the work on one side and have an isolated variable on the other. So what is 3 to the 0 power? 1. Anything to the 0 power, right, is 1. 3 to the 1st power is 3. 3 to the 2nd power is 9. And then you have to graph that. So be careful here because you want your x values first, right? When you are graphing a log, where is your asymptote going to be? The y-axis. Your asymptote should be here. Now plot those points. 1/9, -2. Zoom in here a little bit. 1/9 is really hard to show because you're breaking this little chunk into 9 equal parts. Just do the best you can. 1/9 -2 would be somewhere right around here. Okay, second point, 1/3 -1 is going to be somewhere around here. And then we've got 1/0 is right here. And then 3/1, 1, 2, 3, 1. And then 9/2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2 is right there. If your curve doesn't look like it's going to make sense with an asymptote at the y-axis, something's wrong, right? So make sure your asymptote is the y-axis when it's a log problem. Questions on that? Okay, I want you to try this one on your own or with a neighbor. But tell me first what you're going to be plugging in and for what.
-2, -1, 0, 1, and 2 in the y column.
In the y. So this is -2, -1, 0, 1, and 2. Okay, so rearrange that into exponential form. Plug those numbers in, see what you get, and then graph it, and we'll see if your graph works out. You can work with people around you. Help each other out.
Brian, do you need my help?
Yeah. What to what power equals? Oh, yes, sorry, I thought that was next. Next to y equals. When you have a fraction to a negative power, what are you doing? Flip it over. So we put parentheses around 1/2 because you want to do it in the whole thing. So now to make it on the positive second, you have to
Take 2 times, you got
so 2 over 1 to the second power, or just 2.
Anything with a 0 power is going to be 4.
We got it? Yeah. What did you get for your new equation? What's your exponential function going to be? 1/2 to the y equals x, right? This to this power equals that. Okay, so 1/2 to the negative second power is what? 2 squared, right? Flip it over, 2 to the second power, so that's 4. 1/2 to the negative first power is 2, right? Flip it over, 2 over 1 to the first power is 2. 1/2 to the 0 power is 1. 1/2 to the first power is 1/2. And then 1/2 to the second power is 1/4. Does that make sense? Make sure you're squaring top and bottom, okay, when you square a fraction. Okay, so you have that. Now we graph it. Where is your asymptote? The y-axis. So you're going to draw a dotted line here for your asymptote. And then you get 4, -2. 1, 2, 3, 4, 1, 2 is right there.
Is the y-axis always the asymptote
In a log
in the log?
equation, yeah. So when you turn that log into your exponential, then it will be. Where was I? 2, -1. 2, -1 would be here. 1, 0 is here. 1/2, 1 is right in the middle there. And then 1/4, 2 is going to be right there. So follow that curve. It's going to look something like that. Is that what you got? Yes, hopefully. So just keep in mind, you won't have a calculator for that. Okay, so you have to remember when you take something to a negative power that you want to flip it over and make it the positive power. Okay? Okay, here's where you will have formulas. So this part should be the easiest part of the entire quiz if you ask me, because it's literally just dropping things into a formula. But don't take it as so easy that you don't know how to do it when you get there. So, you guys know what pH is? Do any of you have pools? You probably test the pH of your pool if you have a pool, right? There are a lot of different pH options. You can go all the way down to 0, which means it's very acidic. And it can go all the way up to 14, which means it's a base, okay? 7 is neutral, like right in the middle, right? The average. So there are a lot of things in life that you can test their pH and see, is it something very acidic or something very basic? And there are formulas that will help you do that, okay? So there's a formula for finding the pH of something. And that formula uses logarithms. Isn't that fantastic? Math meets science. The formula is this. It is a negative and then the log of whatever H plus is. And H plus, whenever you see this, that is the concentration of hydrogen ions. So it's like the density, the concentration of how many hydrogen ions you have of something. Okay, that's how they figure out the pH of something. So, for instance, they tell us lemon juice has an H plus concentration of hydrogen ions of this number. Can you tell me what that number is in the format of? 5.0 times 10 to the negative third. We call that math meets science. Scientific notation. That's scientific notation, right? Scientific notation is always a number with one decimal place behind it times 10 to some power, right? So this is in scientific notation right now. When they ask you to find the pH, that number is in scientific notation typically. 5.0 times 10 to the negative third is the concentration of of hydrogen ions. So when they ask you to find the pH, you are literally taking that number and dropping it in to a formula that will be right above that question on your quiz. Isn't that fantastic? So it really is a matter of, do you know how to plug it in? So what you do with this is you say the pH is going to equal negative log, and then you plug in that number, 5.0 times 10 to the negative third. And if you plug it in exactly how you see it, you will get the right answer. So get your calculator out, see if you can get there. Do you think this is acidic or basic before we go? Lemon juice.
Acidic.
Very acidic. Yeah, plug it in. See what you get. Don't forget the negative out in front of the log, okay? That's part of the formula. It is the negative log. Oh, you've never found log, yes. So above on, below second, it's kind of right in the middle there. Right next to 7, log. So negative, it's a negative sign, not a minus. So negative log. Do you have to put in 5.0? You can put in 5, right? It doesn't change it. What do you get? The pH of lemon juice
I got 1.3.
is 2.3.
Why started not again?
What are you doing?
I did it right.
I doubt that.
You got 2.3 or you?
Times.
I didn't negative 8. Eight, great. You just plugged in a negative 8, right? Okay, I was gonna hit it. Oh, yeah, I got it.
I love that you guys. What? Chocolate is?
I'm gonna smack.
Yeah, I would believe that.
Dog, I did
This
it
one,
right.
the next one is
Right.
what's surprising to me. Okay, buttermilk,
I got
2.3.
It's acidic.
There we go.
Okay, but is that what you would expect it to be?
Have you tried it?
I would so expect buttermilk. I guess I've never tasted it just as it is, but I think of buttermilk as like so creamy, right? So then I'm like, oh, it's a base. It's acidic. Who would have thought? Not me. Anyway, sorry, let's finish this one. This is acidic, right? 2.3, that is over here somewhere. 2.3, acidic. Buttermilk, try that one. Plug it in. So your pH is the negative log. Your calculator is going to start a parenthesis there. 2.5 times 10 to the negative fifth. Plug that in. 4.6. So if your pH is 4.6, is that acidic or basic? Acidic. Why do we care? The scientists care. Different things, different acidity levels or base levels impact a lot of things. Okay? Any questions on how you plug that into a calculator? Straightforward? Yes.
On the quiz, are we gonna have to say if it's acidic or not?
I think I usually just ask you if it's a base or an acid. No, if it's what is the pH. I don't think I usually ask if it's a base or acidic. Okay, one more formula, one more problem. If you have to find the concentration of hydrogen ions, first of all, what format do you think your answer is going to be in? Scientific notation, right? They tell us up here the concentration of hydrogen ions in scientific notation. So if you have to find it, you need to put it into scientific notation, okay? This says baking soda has a pH of 8.7. Find the concentration of hydrogen ions. Here's the formula. The concentration of hydrogen ions is 10 to the negative pH, okay? So this would be baking soda is 10. Is baking soda acidic or basic? It's a base, right? 8.7, that's closer to the base side. So you're gonna plug in this, 10 to the 8.7, plug it in, because some of you are gonna be a little perturbed. Oh. What did I do? There we go. Okay, this is what you're probably seeing on your calculator right now. I'm not gonna. Okay, that's not your answer. That's ugly. We don't like that. We want scientific notation. Can anyone tell me how you put something into scientific notation? Dominic. You have to round it first to what place?
The sig fig.
The 10th place, right? We want one.
There's two of them. Two.
Yeah, right?
There's what?
There's two sig times.
Yeah,
So,
so you want to say the
So technically, you would actually, there's actually.
It'll be 2.0.
There we go. Micah wins.
That's the sig fig. 2-0.
Yes, the sig fig. Yes.
That's what I said.
Oh, I didn't hear. I said what, and you all like chuckled.
You're just smarter than all of us.
The sig fig. Yes. This, right? But we need to round appropriately. So this 9 is going to bump that up. You have to keep that 0 there. Don't ditch it. Okay? This is 2.0. And then this is your exponent. An exponent of negative 9. We are doing times 10 to the negative 9th power. Okay? So this is how I want you to write that answer using that sig fig. Yes. Okay? Questions on that? Okay, hear me though. If you don't know how to plug any of this into your calculator, please ask me. This should be easy points on a quiz because I can show you exactly how to plug it in. But if you are not getting this right now when you're plugging it in, I need to help you, okay?